Let's talk about the engineered world first, because most of us, live in a world of artifacts. We live in buildings. We have bridges. We have sewer systems. We have all kinds of human artifacts around us. Well, today, most of those things are not managed. Today, most of those things just, we fix them when they're broken. Think about the tire on your car. You don't do preventive maintenance on that usually. If it blows out, you repair the tire. So a lot of people say, well, we've already received most of the productivity increases from telecommunications, from the digital revolution, and those are in the past, and there aren't going to be that many in the future. Well, what I want to talk about with Sensornetics is that there are whole new applications of the way we use telecommunications that nobody is really focusing on the way we ought to be. And that's what Sensornetics is about. Today it's possible to have small aspirin-sized, sugar cube-sized sensors, micro telesensors that have wireless radios on them that can be used to manage the engineered world. So that instead of waiting until a tire blows out, we sense the air getting hotter or the pressure going down, and that tells us to stop. And so the whole idea of Sensornetics is to understand the next wave of productivity increases. The first wave was computers. The second wave was broadband. The third wave will be a world of sensors, where everybody is hooked up to sensors and everything. I think the interesting thing about Sensornetics is that with nanotechnologies and micro manufacturing technologies and small sugar cube-sized micro telesensors, it's possible to retrofit things very cheaply. And you think about in the United States, 2 years ago we had a bridge collapse in Minnesota that killed a lot of people. Well, if we had micro telesensors on the bridges to look for stresses and to be able to notify the maintenance people when stresses are beyond a certain range, then those kinds of tragedies wouldn't have to happen. And today we do a lot of preventive maintenance. Well, that's a very expensive kind of maintenance of the engineered world. So, for example, if you take a convenience store, the biggest cost in a convenience store is refrigeration. And the compressors that drive those refrigerated units wear out. And so what they do is they replace them, on a preventive basis. But many of them, maybe if they run for, let's say, 50,000 hours, on the average, they'll replace them at 40,000 hours, but some could go for 90,000 hours. So now we have sensors that can sense when a compressor is about to fail, 6 or 8 hours ahead of time, and that sensor will automatically send a signal to the internet, which will send a signal to a vendor who will come out and replace the compressor before it dies. What happens in convenience stores is that when these compressors fail, the refrigeration unit goes down, the food spoils. Nobody knows it's spoiled until somebody eats it and gets sick. And so, we have ways here of saving a huge amount of money on the one hand and protecting people's health and safety on the other. And it's that next step, that next wave in productivity improvements that's going to come with sensors that will follow on computers and broadband that I think we need to start thinking about. Infrastructure is one of the most important things for any society or community. And I think the SMART program here, the SMART facility, is really an important world-leading institution with huge potential to have influence on how we think about the engineered world. And so I was very pleased to get an invitation to come here to talk about these things. Look, a lot of this is going on, but people haven't put their head around it in a coherent way to think about what's happening. And many of these things have been going on for a long time. Think of the thermostat in your house. The thermostat in the house reads the temperature goes too low. It triggers an actuator that turns on the furnace that makes it. So that's what we'd call an M-to-M sensor, machine to machine. Then there are machine to people, M to P sensors. And a good example of that would be the fuel gauge in your car. It goes down, it says E, and so you go to the filling station and fill it up with gas. And so there are all kinds of sensors out there. What's different today is they're smaller, they're cheaper, and they can be retrofitted, and they're wireless, and most of them will be M-to-M systems, machine-to-machine systems, so that human intervention is not required. When I left Telstra in October of 2008, I went back to the U.S. and I started writing a book, and I just finished it. It'll be coming out this month. It's called Reboot: What to Do When Your Career is Over, but Your Life Isn't. And the whole idea of Reboot is that we should never retire. We should retire the word retirement. We should die with our boots on. Retirement is a disease that will literally kill you, and so we have to find a way to help people who are now thinking about retiring at 65, who probably have 30 more years of life and 20 more years of productive life, how to change their thinking about how they live out their later life.